Good morning to all of you. Respected Chairman Dr. A.K. Nadesan, Honorary Chairman ISTE Tamil Nadu and Pondicherry Section and Chairman Excel Group of Institutions. Respected Principal Dr. V.K. Shanmuganathan, Principal Excel Engineering College. Dr. Palaniswamy, Professor Sivakumar, Professor Ratanavet. So there are 3 CIT alumni. So Dr. Shanmuganathan is BE Mechanical Engineering from CIT. Ratanavet is from MBA Applied Electronics from CIT. Sivakumar is BTech Chemical Engineering from CIT. I am happy that we have 3 alumni on the stage. Respected teachers from engineering colleges and polytechnic, members of ISTE, invited guests, students, members of the press, once again, good morning to all of you. It is a right topic, innovations and challenges in technical education. Yes, of course, innovation is the currency of this millennium. The reason is, unless we go by innovations, it is very difficult to meet the challenges faced by the society. I am happy Dr. A.K. Nadesan addressed this gathering that has a lot of meanings. Now if you take the European, like the German, always they will call it as German price and German quality. If you take any product, if you purchase any product from Germany, everything will be costlier and the quality also very high. Now the life cycle of the product will be very high. What do you mean? That means they apply all their minds, all their knowledge to create new idea so that they can give the best quality of the product. Wherever it is, whether it is a hardcore product, software product, service product, anything if you take, German, if you go, it will be, they will always call German quality and German price. It will be the cost will be very high. The quality also, the deliverability from the product also. That means the quality of the product will be very high and the life cycle will be very high. So what is the scenario around the world? What do they expect from the engineers, technocrats and scientists? They expect a lot from us. The reason is the changing scenario. Now for example, if you take energy, water, these 2 are the parameters throughout the world people are looking for. Now just leave about the defense. Now for example, we are launching, even the other day, our Honorable Prime Minister Modi pointed out that we have spent 7 rupees per kilometer to reach the Mars. Now I am proud to say the Mars director is our CIT alumni, 1984 mechanical, Aruna, who did the entire project. So we something wrong. I think I can talk freely without that. Now the type of education that we are giving to the entire world is the fundamental education. So that fundamental education only will help you to improvise the knowledge. That means we cannot skip mathematics, physics and chemistry as engineering faculty. Now it is common for both engineering and polytechnic. Maybe in engineering we are focusing more on design, research and innovation. But in the polytechnic, design, manufacturing, and then it is called the the skill. It is called the technical skill. So this side, in the university education system, we are requiring the design and research skill. In the polytechnic side, we are requiring the design and manufacturing skill, where whatever you innovate, whatever the research that you are doing, completely we are converting it into the product with the help of the skill that we are impinging on the young minds of the students. That is the difference. Otherwise, both are related, both knowledges are required. If you have the regular skill, that will be useful for the on-the-job work. If you have the design and research and innovative skill, definitely you can invent some new idea. Now always the scientists invent, the technologies convert that invention as the product or in terms of concept. So we, the engineers, we have to implement those science and technology to give service in terms of product, in terms of service, whatever you call. Now, anything. Now, for example, if you take the automobile technology, I have seen three types of technology in my life. The first generation computers, if you take, when we were student in the Madras University, so 1977, we were given the calculator. And that calculator, it was bigger size, almost some 6 inch by 4 inch, thickness of 2 inch. So that Aristo calculator we started using. Then afterwards, after 10 years gap, the integrated chips started coming, what you call the specialized integrated chips. So with that, the complete calculator was simplified, and the computers, even during my PhD in 91, so we had the, what you call the XT computers. So we wrote a program for 7 components and 3 machines. It took about, for the simulation, near about 20 hours to get the total program. We used to sit in the PhD Tech CAPCAM laboratory, so continuous monitoring of the program. My ME students will help me to run the program. Continuously the output will be coming. Then after the extended technology, we got the advanced technology. Then the 386, 486, likewise Pentium. There are so many processors. Now, with the help of the mobile computing, it is possible to convert, to write a program for n number of components and m number of machines. That means it is like your timetable that we are making in the classroom. In the shop floor, if you want to assign the components to the machines, assign the tools to the machines, assign the manpower to the machines, now it has become very simple. So 3 types of technologies have come. Now, with the help of the new technology like the nanoscience, it is possible for us still, you can imagine about the infinity type of components, infinity type of machines. So that will help you to improvise the productivity. That means any system that you are adopting, always we are interested in the quality and the productivity. The same concept you can implement in the hospital, you can implement in the hotels, even in the educational institutions. No, even for your assigning the classroom. No, actually we are having a program. It is called the university management system. So we are doing the timetabling, everything with the help of the software, starting from the attendance. So that becomes easy for us. The adaptability of the technology helps us to minimize certain error, to improvise the quality. So that's why, as Dr. Nadesan addressed, you have to implement the new technology in your system. Now I'll come to the 2 parameters, important parameters, that is, I told you, the water and energy. Now what it says, now that means the compartmentalized engineering concept, it is gone now. Now wherever there is a QS rating, if you just type QS rating, you can find the institutions like Massachusetts Institute of Technology, Imperial College, Oxford University, Stanford University, Georgia Tech. Now, likewise, there are so many institutions, Carnegie Mellon, lot of schools will be coming in the QS rating. If you just go through their departments, go through the research facilities that they are having, if you just make an analysis, always they will be comparing about how the society wants, what is the need of the society. From that is the backward planning. They will start from the society need. From there, they will design. So what is the science and technology we are having? What are all the science and technology required? So how to implement? For example, simple example, if you take the energy engineering, this energy engineering, of course, everybody know we are having the renewable energy. So wherever I visit, they used to tell, India, you are having a lot of abundant solar energy and water resources. Why don't you use this renewable energy to uplift your energy requirement? That's what the leading professors in leading universities, they used to tell. That is, they are already aware about what are all the facilities available in terms of the resources. So how to use this? No, lot of maybe the teaching faculty in engineering college, you can think about something like, you might have heard about called business analytics. All the software engineers will be talking business analytics. That means all your 0 to 9, A to Z, with all the symbolic notations, you are writing a program to connect your mind and connect your machines and connect your product, connect your services. So how to put it? That business analytics that will help you to improvise the service. That's why the energy resources available. For that, you have to identify what are all the resources available, first of all. Based on that, using your, no, they will use a terminology called business analytics. No, that is a new terminology, but it is all old wine, the new bottle concept. So earlier, all our calculations, if you take our Panjangam, in that you can see, without knowing the calculations, our old people, forefathers, so they have written the sunrise and sunset, the same calculations with all the telescopic facilities. Now people are calculating, how the sunrise, how the sunset is happening. Already we have the mathematics in India, but we have not put it in the right direction to the right job. So that is why we are not able to compete with the Western countries. So that is the reason. But those who are going from here to Western universities, since we are having the fundamental mathematical concepts in our mind, they are able to shine in all places. If you take Microsoft, you can find a lot of people. If you take Google, you can find a lot of people. Even if you go to NASA, when we visited the Houston facility, we found a lot of people from India. A lot of people are contributing to the core technology. So that is the fundamental concept behind it. If you take this energy sector, especially, if you apply your business analytics, you can calculate. So how this solar, how to, capture the solar facility, how to capture all the, water resources facility, how to convert the forces available or the temperatures available to our new technology. There are a lot of, now you see the nanotech, if you take the physics subjects, always we are talking about the physics of materials. We are talking about the nanotech technology. So with the help of nanotechnology, we are able to reduce the size of the material. So that we are talking about 10 to the power of minus 3 meter, now we are talking about 10 to the power of minus 9 meter, which helps you to, have the binding capacity. So that binding capacity helps you to give you the deliverability. For example, if you go through the Boeing website, you can see the new aircrafts like the Dreamliner or the A380 of Airbus. You can see that they started using this nanomaterial, that nanomaterial in the form of composite material. So they have reduced the wall thickness of the sheets that they have used for the construction. So with that, they were able to improve the efficiency and the timing also. They are able to improve the speed also, and the the consumption of fuel, that also reduced. So whatever the exhaust that is coming out of the aircraft, so that also spoiling the outside atmosphere. So for that, they were doing continuous research for about 15 years. Through that, they are able to reduce. You see the advancement that is taking place. So for those research, where the knowledge comes from. If you take any university, they will talk about, one is energy, they will talk about water, then they will talk about the healthcare engineering. So that is, you see, earlier we were talking that medical doctors. Now the terminology has changed. It is called the healthcare engineering. So how to use this concept? Now that healthcare engineering, you need complete science. Again, whatever the medical doctor is studying, the same concept. Only thing is, we are connecting the concept with the instruments available. We are connecting the computers available. We are connecting the softwares available. Now recently, I had a chance to visit Imperial College in London. If you go through that website, you can see Hamlin Center. It is the medical electronics center, where the robots are performing the operations. That means sitting in your home, the doctor sitting in the home, using the mobile robo, they can perform the standardized operations in the hospital. Even if sometimes, if you are not able to transport the patient to the hospital, you can take all the facilities. So that's why the new terminology they have created, it is called the telemedicine. Telemedicine means not only prescribing the medicine, it is in terms of helping. Suppose one patient, we are not able to move to the hospital, so you can have a transport facility, you can create all the hospital atmosphere in a bus or a lorry, whatever it is, the model that you can create. You can take it to the place of the patient and you can perform the operation without the doctor, with the help of the robot. Sitting in the hospital, the engineers and doctor they can write all the programs. Using that, they can completely perform the operations. There we have seen how the importance of robo. Robo, normally we think that it is used for only in industries. It's not it is used for in all applications. Recently, last week, I visited the National University of Singapore and Nanyang Technological University. So there also, they created the concept of healthcare engineering. They have introduced a lot of robotics operations in this. So they call it as the medical electronics. They have small products in medical electronics. So through that they are able to use the doctor's knowledge and use the engineering knowledge. Now, anything if you take, suppose for example, if you want to study the total pressure of our body, the flow of our blood, for all those things, they use the concept of the computational fluid dynamics, which we studied in our physics, the fluidics, the concept of Bernoulli's theorem. The simple Bernoulli's theorem, using that, the complete flow analysis, the engineer is able to write and give the program, through the program to the doctor. So that is in terms of finite element, starting from your top of the head to the toe, they are able to give every point what is the pressure. So based on that, the doctor can take a decision, so what happens to his complete body. Similarly, the nerve, the complete nerve system, it is all with the help of the computers and software available, we are able to create an equivalent model through the simulation. Finally, for creating a model, you need the simulation languages. Now that helps you to improvise the system. Obviously, in the in the field of healthcare engineering, lot of technologies we are introducing. Now, I visited this Singapore Institute of Manufacturing Technology in Nanyang Technical University. Now, for anything, suppose for example, if there is a bone fracture, if you want to replace with the help of CNC machines, it is called rapid manufacturing. They are able to completely fabricate with the biomaterial. They are able to replace the total, complete the bone wherever the fracture is, wherever the portion of the bone to be replaced. So for all those things, you require the knowledge of the engineers. So how to put it in our regular academic like this? Now likewise, we can go on talking energy side, a lot of things, healthcare engineering